In this video, we are going to discuss about the Schmitt trigger. So, on completion of this Schmitt trigger, students will be able to study and design the integrated circuit using op-amp using this IC741. So let us see about the Schmitt triggers. So Schmitt triggers are commonly implemented using an operational amplifier, or it is commonly implemented using a dedicated comparator. So this op-amp or op-amp and comparators may be considered as an analog digital device, which we are having the analog inputs and the digital output. Here it extracts the sign of the voltage between its two inputs. So normally this Schmitt trigger is mostly used to convert the slow varying ranges. That is, the purpose of this Schmitt trigger is to convert any regular or irregular shaped informed into a square wave output voltage. So this we also call it as squaring circuit. And here comparators are the simplest way to create the binary signal with this op-amp. While taking the advantage, it has a high gain of the chip to force to saturate either high or low, that is creating two binary states. And in the case of the Schmitt triggers, it is a modified version of this comparators, which is using the voltage divider to improve the performance of the comparator in the presence of the noise. And here this operational amplifier comparators, the prototype of this operational switching amplifiers is nothing but the op-amp comparator, so it does not employ any feedbacks. So since we have the large gain, the characteristics of this open loop performance is greater than 10 per 5, that is small difference between the input voltages, which will cause the large outputs. So that is our op-amp will undergo saturation at every extreme according to the voltage supply and also the voltage polarity. One we can take into an advantage is that it can generate the switching waveforms. So we are considering the non-inverting operational amplifier comparator. Sigma is equal to epsilon is equal to V cos omega t, and this comparator, this is nothing as simplest form of the analog to digital converter. So here this Schmitt trigger is also called as the regenerative comparator, that is it is designed with the positive feedback, and also this produces a regenerative action so that this will make the output switch levels. So also while using the positive voltage feedback instead of negative feedback, the feedback voltage, this aids the feedback voltage to the input voltage instead of opposing it. So that the use of the regenerative circuits is to remove the differentialities in the zeros crossing detector circuits due to its low frequency signal, also its input noise voltages. So here we can, it is easy possible to construct an inverting a comparator by connecting the non-inverting terminal to ground and connecting the input to the inverting terminal. And here let us see the comparator with the offset. So comparator with the offset is, we are assuming the inverted input voltage is having the slight positive value, so this will cause the negative value in the output, and also the negative voltage is fed back to the non-inverting terminal. This will the value of this negative voltage will be set as a feedback to the positive terminal. So there will be a rise or fall in the voltage levels that will switch from one extreme to the another. And one effective way of improving this performance of this comparator is to introduce positive feedback so that it will increase the switching speed of the comparator and provide the noise immunity at the same time. So the voltage range over the signal does not switch, which does not switch, is called as the hysteresis. And also here we can see the value of the positive voltage is fed back to the positive terminal, that is becoming very higher, and also the value of the positive voltage becomes again higher until the circuit is driven to the positive saturation. So if you are designing to switch about a voltage other than the zero, a reference voltage can also be used to connect to the non-inverting terminal, that is switching levels is Vn is greater than R2 divided by R2 plus R1 in the case of the positive going transition. In the case of negative going transition, Vn is less than or minus R2 divided by R2 plus R1 into Vsat plus V reference into R1 divided by R2 plus R1. So these are the equations for determining the switch levels when we are seeing about the comparison with the input and the output voltage. And there is an example when reference voltage is equal to 1 volt and V saturation equal to 15 volt or minus 15 volt, then we can see the V saturation value for a positive voltage and negative voltage, so which we are denoting in the form of the upper threshold voltage and lower threshold voltage. So mainly if it is upper threshold voltage, we call it as this V out is equal to minus V sat, so that this voltage will be slightly more negative than the V lower. So in order to cause the output to switch from the minus V sat to plus V sat. So these are the possible questions for the Schmitt trigger. Which circuit converts irregularly shaped waveform to regular shaped waveforms? A Schmitt trigger, second voltage limiter, third comparator, D none of the mentioned. Thank you.